So back to our 8-step plan. So we introduced types and typing and how they work. The primitive types and operations, control flow, you've seen, there's if-then, same as in any other language, nothing special there. But let's talk about functions and procedures, and let's talk about abstraction and encapsulation. And for a couple of reasons, with JavaScript, we sort of have to talk about them together. And then we'll move on to these other topics. OK, objects and prototypes. This is one of the things that's just different about JavaScript. JavaScript does have objects, and it does have inheritance. But at least up until ES6, which we're not covering today, it doesn't really have classes in the sense that a traditional object-oriented programming language like C++ or Java or even Ruby has classes. Instead, the object inheritance model is based on this alternate concept called a prototype. And the basic idea is that every object that is newly created has a prototype. If not otherwise stated, then its prototype is just the basic object, which is you can think of as an empty hash. And if you try to look up a slot or dereference a property of an object, and the object doesn't have it, then its prototype is consulted, and so on up the chain. So there are some ways in which this behaves similarly to inheritance and classes, and some ways in which it behaves quite differently. In particular, the reason it's called differential inheritance is that any object instance can modify any one of its slots, essentially overriding, right, like the behavior of its prototype. But whereas in traditional object-oriented programming, I could have a subclass that overrides a method of the superclass, but now every instance of the subclass has that overridden method. In JavaScript, every copy of the object can potentially have its own version of the behavior. So it doesn't have classes in the traditional sense. So let's look at a few lines of code and sort of see what this means. One kind of object in JavaScript is a function object. Basically, it's an object that is function valued. And here, I am defining an example of one. And I'll get back to why I've capitalized the name of the variable in this case. But it is a convention. OK? What I have done is I've created a function object that kind of behaves like a constructor, but not really. And if I call this function object down here, and I say new movie, and I pass the 3 arguments that it expects, what does this function actually do? Well, inside the function, this is referring to a new object that is being created. So I'm setting the properties on the new object to be the things that were passed in. I'm also defining 2 functions. So again, you can sort of think of these functions as instance methods, because once I've got a copy of an object that was based on this prototype, right, that just means that the pianist is an object that is built from this template. And it literally means that. It means that I took this entire template and I cloned it, but within the clone, I've changed the values of particular slots. The clone has its own copy of these functions, OK for kids and full title. But it can decide to overwrite them, right? So if in my specific object, I have overwritten the value of the OK for kids function slot to be some new trivial function. And that doesn't have any effect on any other copies of the object I've made. So if I had several more lines here where I have additional variables, and for each one I'm creating a new object copy, I can basically customize the behavior of every single one. That's the difference between prototypal inheritance and the kind that we see in traditional object-oriented languages. Think of it as like once a copy of the object has been stamped out for you from the prototype, within that copy, you can modify its individual elements, and not just its data valued elements, but its function valued elements. And every object can have sort of its own behavior. That's part of the heritage of self. A huge, 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 huge pitfall in JavaScript is this. Well, actually, there's 2. Even though I've defined movie as a function, notice that I'm calling it with this keyword new in front of it. This is really important. So that's your cue if you haven't been paying attention to what's really important. I'm going to tell you a thing that's really important, because this bites people in the butt all the time. It would be perfectly syntactically legal if I take out the word new from this example. This is a legal JavaScript expression, because movie is a function. I have some arguments. I'm just calling the function with some arguments. However, you should probably not do that if the goal of this thing is to act as an object constructor. The tip-off of new is exactly the difference between just call the function versus use the function to create a new object of which this thing is the prototype. That second thing is almost always the one you mean. You almost never mean this. In particular, the return value of this is undefined, which is really counterintuitive. So even if this function had an explicit return value, which you can see it doesn't because it's going to construct a copy of an object, new means that's the object that I actually want returned here, right? Stamp out a copy for me of which this is a prototype. If I leave that out, then what I'll get back is an undefined value for the pianist. It will not be a copy of a new object. It'll be undefined, which is JavaScript special value for a thing that has a name but has no definition. And that is almost never what you want, and it's tricky to debug. That is the reason that by convention, JavaScript programmers have adopted that you capitalize the name of one of these constructors if the way that it is supposed to be used is not as a regular old function, but as a constructor to make new objects with this kind of prototype. So if I had defined a lowercase movie, that would imply that that's just a plain old function. I'm going to call it, and it's going to return a value. If I'm defining capital movie, the implication is this is designed to function as a constructor. So if you ever see a call to capital movie without the word new, something is probably wrong. Okay? So by the way, many people consider this ambiguity to be the single worst syntactic design flaw in JavaScript. So you're fair warning. Another pitfall, the one highlighted in yellow down here, recall that in Ruby, a function call to a function that doesn't take any arguments, if you combine that with the fact that Ruby allows you to leave out the parentheses when it doesn't cause a parsing ambiguity, this may look like it's just a call to a function that you're not passing any arguments to, but it isn't. Actually, this expression refers to the function itself. So, and one of the idioms that we'll see in JavaScript quite a bit, actually, is that functions get passed around all the time. So, pitfall. In JavaScript, to call a function, you have to put the parentheses around it. Even if the function takes no arguments, okay, then you have some empty parentheses. But if the parentheses are not there, you're not actually calling the function. You're referring to the function itself. And in a couple of slides from now, we'll show some examples of the 1,000,001 places in JavaScript where that is exactly what you're supposed to do, is refer to the function itself. OK, so just to summarize, when you're calling something that is a constructor-like function to stamp out a new copy of an object having this as its prototype, make sure you use the word new, because otherwise you'll get an undefined return value, and it'll take you forever to debug, and then you'll hate yourself. Any questions about my little snippet of code on this slide? This is to start getting you accustomed to what the language looks like. Yeah?
So earlier you had called movie up, or you made JavaScript object notation for up, and it was just bar movie.
Let's find it.
It was 7 or 8 slides ago.
Yeah, I'll find it. It's here somewhere. There? That one?
Yeah.
OK.
So in this, if we were to just call movie, then that would spit out the JSON.
So in this case, in this expression, what is the final value of movie? It's just an object. It's not actually a function at all. Okay? So here, movie just refers to this hash. You can't call it because a hash isn't a thing that you can call. Whereas in the slide that we were just on, so in this slide, the value of movie is a function, right? So in this case, the value of movie is a thing that you can call. You can try to call anything, but if the thing you're trying to call isn't a callable thing, it's just an error. So the fundamental difference between the previous slide and this one is that here, I'm defining movie to be a function. That's what allows me to talk about calling it. Does that help at all?
Yes.
Yes with a but, or yes?
Yes. Basically, what confused me was that you're calling this bar, or you're saying bar movie, and then you have the JSON right there. But if you wanted to refer to something else as, say, another movie, The Pianist, then you would have to call that also The Pianist.
Right. So the way to think about it is movie is just a variable name. And a thing that you cannot easily do in Ruby is you cannot assign a function-valued object to a variable name. In JavaScript, you can. And that's the confusion. And this is why when most people who are coming into JavaScript from C or C++ or Java, none of which have first-class functions, right? A first-class function means a function has the same standing as an int or a string or an array. It is an object that can be passed around even if you never call it. For most people, JavaScript is the first language they work with where that's a thing. And it's a really important thing because that ability, that property is actually used all over the place. So in this example, I have created a variable whose value is a function. In the previous slide, I created a variable that happened to have the same name, but its value was just a plain old object, a hash. And hopefully there's a little more code coming up that I think will even make the distinction even more clear. So thank you for asking. Other questions on anything on the, any questions about my little code snippet here? Yeah.
Do you have to do bar m equals new movie, or just do bar m equals one?
If you mean like what happens if you leave out new?
Yeah, when you're trying to refer to the function itself.
Oh, yeah, if you're trying to, yeah, the example is a little contrived because you wouldn't really want to refer to this function. But yes, if you left out new, yes, you're right. In fact, actually, I'm not even sure that new is legal in this context. But yes, this assigns m to the actual function object. It doesn't call the function. It just makes m point to the same thing, which happens to be a function valued object. Right? Functions are fun. We're going to learn to love them in just a moment. OK, so other questions on the code? If you get this concept about function valued objects, you're halfway through today's lecture in terms of the important concepts. So summarizing JavaScript's single worst syntactic design flaw. If you call a function using new, then what you're going to get back is a new object whose prototype is the thing that you called using new. So think of it like initialize in Ruby. It's basically stamping out a new instance of something. The instance is a copy of the prototype, but once you've got that copy, you can modify its individual properties without affecting the prototype and without affecting any other instances that were similarly created. If you now take that thing that you got back and you call a function on it, then within the body of the function, this is bound to whatever the object is, just like self in Ruby. So once you've created an instance of a class and you call a method that is an instance method of that class, within the instance method, self means the copy of the object that received the call. Same thing in JavaScript. This refers to the specific JavaScript object that received the call. If you call a function without a receiver, so if you see a function call that doesn't have an explicit receiver on it, in other words, just like in Ruby, if there's no receiver, the receiver is assumed to be self, and then you have to figure out, OK, well, what is self bound to in that context? Same thing in JavaScript. If you call a function and there's no obvious context in which it's called, this is assumed to be prepended to the front of it. And if there's, by default, this is the global object, which is almost never the thing you want. In the case of a browser, the global object happens to be a thing called window, which has a bunch of properties about the window being displayed. In a non-browser context, the global object will be something totally different. But be very careful if you're calling a function without an explicit receiver. And finally, if you have a constructor-like function, but you forget to put in the word new, unfortunately, it is not an error to do that. It is legal, but it does a thing that you probably didn't intend, which is that you do not get a brand new object. Instead, you get undefined. And then good luck debugging that, because that's the equivalent of trying to, getting an error message that you're trying to call some method on nil, and it's not defined. OK, continuing on the 8-step plan. That was step 3, where we were talking about functions. And I said that together with that, we were going to talk about abstraction and encapsulation. They sort of go together. So I think one of the things that last example drove home is a function is a first-class object. You can pass a function around, which is different from calling it. And that's extremely common in JavaScript, is passing functions around for reasons we'll see in a moment. Functions are also frequently property values. So even in that clicker question that we just did, the object that we were defining, that square constructor, it has a property that is the length of the side of a square. That's just a plain number. But it also had a property that is function valued, which is a function that computes the area based on the side. So they feel like instance methods, although we don't really have classes, so they aren't really instance methods. We'll talk about ES6 separately, but what you saw was an example of prototype inheritance, where you stamp out a copy that has the same slots, and it can just look up the slots in its ancestor. We've seen the var keyword a number of times here. Basically, it restricts the scope of a variable to the function within which it occurs. It is almost never the right thing to leave out the word var, because if you leave it out, it's implying that your variable is being declared globally. And you almost never want to declare variables in global scope. The one exception is, well, then how do you sort of keep track of all the stuff that is associated with your app? It's considered a best practice to create a single object and give it a name that's in the global scope. And then inside that object are the properties that store all of the functions and all of the data that your app cares about. So, for example, I might have some JavaScript code associated with my Rotten Potatoes app that looks like this. The first thing it does is it defines a single top-level variable. So because it doesn't have var in front of it, this is going to be defined in the global scope. The initial value of RP is an object that has no properties, so think of it as an empty hash. But I'm immediately going to start creating new properties in that hash. I'm going to have a setup property, and that's going to be a function that maybe does some setup things when the page is first loaded. I'm going to have another property called getMovieInfo, which is another function that maybe makes an AJAX call to the server, about which more on Thursday. Another way to write this would have been something like this. In one fell swoop, I can create a single object and say, here's my opening brace of the object, and here are the slots. Same thing. One reason that I will often use the top form is because as long as I know that some JavaScript file has been loaded early on that creates a definition for this object, then in my other files I can add other properties to it and not worry about polluting the global namespace. Okay, so multiple ways to sort of keep track of what all is in your app, but this is a recommended thing is your app is going to add at most one thing to the global namespace, and because that thing can include arbitrary nesting, all of the stuff related to your app-specific JavaScript functionality is in there. Any JavaScript functions that you write are just function-valued properties. Any data associated with your app are JavaScript slots. Of course, keeping in mind that as soon as another page is loaded, that all gets blown away and reinitialized, because every page is a brand new, fresh copy of the interpreter. OK? 8-step plan, moving on. So we've talked about types, typing, methods, abstraction, encapsulation. Let's talk about JavaScript idioms. And again, this is where there are things that are very common in JavaScript that most people have not experienced coming from other languages, unless they've done like Python or Scheme. So if your 61A chops are still good, this will be easier. OK, passing functions around. One of the most common JavaScript idioms, in fact, it's almost impossible to get any serious work done in JavaScript in the browser without using this idiom, is the idiom of passing a function to something, usually because that function is going to be called at some later point in time for some reason. For example, in the early days, before there were JavaScript frameworks like jQuery or anything like that, one of the standard calls that was provided by the browser's JavaScript API, and remember that document is a thing, if there's no qualifier in front of a name, it's assumed to be this, and in the global scope, this is the global object. So this, I could have also written the first line, this.document.ready or window.document.ready, because for a browser, the global object is a thing representing the browser window. So in this first line, one of the standard calls that a browser would provide was called the ready function. And what you pass to the ready function is a function. And the browser promises that once the page has been completely loaded from the server, it will call any of the functions that are in the ready list. You can actually have multiple ready functions. Why do you need this? Because, for example, you might have JavaScript code that expects the page to have been loaded, expects some element to be somewhere so that it can animate it or highlight it or whatever. But in fact, the order in which the browser loads chunks of the page and chunks of JavaScript is not necessarily predictable. So the ready function provided by the browser gives you a hook that says, when you, the browser, can guarantee that everything is like ready to go and fully loaded, then call my setup function, and my function knows that it's going to find everything organized in the right place. But here's a valuable example of where you're not calling the setup function at this point. You are passing the function itself because the expectation is someone else is going to call that function later. When frameworks like jQuery started to pop up, they actually replicated that same idea. They have a notion of a ready function, but jQuery does a bunch of other stuff for you and then calls all of your ready functions by it, because it will arrange to pass them down to the browser. So in both of these cases, the key idiom is you're passing a function because someone is going to call that function later under some well-defined set of circumstances. Another idiom that if you're reading complex JavaScript code can look a little bit disorienting is what's called immediate application or calling a closure. So suppose you see something like this. Function, a bunch of stuff in a function. Maybe the function has some side effects. And then this is what I call like the jungle of JavaScript parentheses. You're going to lose many valuable hours of your life counting and matching up braces and like curly braces and parentheses in JavaScript. So use an editor that understands JavaScript. But what's going on here? First, we're defining a function, and we're not assigning it to a variable or anything, right? We're just saying, here's a function that does some stuff, doesn't take any arguments. Here's the end of the function. So the value of everything from this open to this closed paren is a function object. Then we put empty parens around the function object, so that causes the function to be called, right? So we created a function. We didn't assign it to anyone. It has no name. We can never reference it again, and then we immediately call it. The reason to do this is because if this function has side effects, it creates new variable names, none of that stuff will escape the application, won't escape the closure of the function. So anything that happens in here, in some sense, is saying, here's an environment. Remember environments from Python, environment diagrams? Everything in here is an environment. And the function is now going to be applied. We're going to call the function. Once that's done, that environment is blown away. It evaporates. So anything that we defined in here, any side effects that we had, whatever, the side effects will still happen, but we're not going to pollute the global namespace. It's a way of containing the pollution of variable names and things like that. And this is an extremely common idiom. A function is defined in place, immediately called, and then never spoken of again, because we didn't assign a variable name to it, so we can't like refer to that function anymore in the future. Another JavaScript idiom that involves passing functions around, iterators. Very much like Ruby. In fact, each is a method that is defined, it's defined basically in JavaScript, but jQuery defines its own method. In jQuery, you can say something like, find all of the HTML elements that have the CSS class called SomeClass, and then on each of those elements, here's a function saying what to do to it. Actually, this is a typo because there should be an argument here, which is the thing that matches each element. Let me fix that in real time. There. OK. Wait, I screwed up the formatting somehow. There. OK, fixed in real time. So, which is, by the way, which is a way of saying, this is just like in Ruby, right? When I call jQuery with some selector that is going to potentially match a bunch of elements, what is the type of the return value of that? Because it's not really an array. It is an enumerable collection. So just like in Ruby, the abstraction of saying, I have an enumerable collection, and I'm going to call each on the collection, and I'm just going to provide a function saying what to do with each element, but the implementation of how the elements are traversed is not up to me. Right, so it's very much the same as the Ruby idiom, although here we're explicitly passing a function, and each time through, a single matching element is going to be passed to the function, and you can do whatever you want in there. Another way to express the same behavior is in my single top-level global object, maybe I've already defined a function that, given an element, does something interesting to it. And now I can say, for every element that matches this CSS query, I'm just going to pass my function into each. Exact same thing. The only difference is that here I have the function explicitly spelled out. Sometimes it's called a function literal because I actually have the function spelled out in line. Whereas here, the function has already been assigned to a variable, a function-valued variable, and I'm just passing that instead of defining the function name. Okay, but what the overarching idiom in all of these cases is, here's a function, and you're going to call it in some specific context. It could be that you're going to call it when the page is ready. It could be that I'm going to ask you to find elements matching some criterion, and then you're going to call the function and pass it each element in turn. But passing functions around is one of the big abstractions that is used everywhere. And by the way, when we start talking about AJAX, it'll become clear why this is an important abstraction. Because if you make an HTTP request to the server as part of an AJAX call, that request could take quite a long time to come back. And I said earlier that JavaScript has no concurrency. It's a single-threaded language. So if JavaScript were to just sit there and wait for the server to reply, then in that intervening time, the user interface would basically be frozen, right? JavaScript would be unable to respond to actions happening in the UI because it's sitting there waiting for the answer to come back. So in fact, the way that those calls are always made, and this is the subject of the next slide, is make the call to the server, and here is a function. When the server returns an answer, pass the answer to that function, and that function will do whatever. And it's up to the browser and the runtime system to figure out when to schedule that as part of the single thread that's in the interpreter. So here's what that looks like, because this is the other very common pattern that is used to handle basically any kinds of UI events. So suppose that, again, following my good habit of only defining my own functions in the namespace of my global object, I've defined a function that takes some data and it does something if there was a successful call. So let's say I'm making a call to a remote API, and hopefully what I'll get back is data. That would be success. Or I might get back an error message. And I've defined two different functions. One of them is the thing to do with success. The other is the thing to do with failure. And maybe what I do is now I'm going to make an expensive API call. I have some way of arranging to make the call so that when the call eventually completes and the underlying runtime system notifies the JavaScript interpreter, hey, this call has a response, then depending on whether the response was a success or a failure, I've passed both functions and say, here, call the appropriate one of these. In ES6, there is a generalization of this, and it's actually also defined in Node.js called a promise. And a promise is basically an encapsulation of the state of a long-running operation whose result won't be known for a while. So here's another formulation of the same thing. Under the promise syntax, basically anytime I create a promise, I have to pass it a function that has two arguments, a thing to do if the long-running operation succeeds and a different thing to do if it fails. They're usually called resolve and reject, although they don't necessarily have to be. So in my make expensive call function, what I'm going to do is I'm going to do whatever the long-running thing is. And if the long-running thing works out, I will call the resolve function. If the long-running thing does not work out, I'll call the reject function. And then in my code, and if you've read code that is designed to run in something like Node, you've probably seen this, right? Whoops, hold on. Yeah, so make expensive call, then something, then something. This is basically a way of saying, if this were a blocking language, I would just do these things one at a time and wait at each step. But this isn't a blocking language, and each one of these things has to be handled by kicking off the expensive operation and relying on a callback to be called at the right time when the response returns. Because that sort of code is difficult to read, then promises and this syntax for then were essentially invented as a way to make it read the same as if you were doing a strictly linear blocking implementation. And to me, this captures why JavaScript makes, to me anyway, a lot more sense to use for the user-facing part of an application than to use for the server-side part of an application. Now, this is a matter of opinion, but let me explain where my judgment's coming from. If what you're doing is enriching the user experience of a UI like the browser, you don't know when the user is going to do an action and what action they're going to do. So basically, your life is spent waiting for the user to do something interesting and then reacting to whatever the user did. Or if what the user does causes a request to go to the server, now you're going to have to wait for the response from the server and do something to react to whatever happened there. So in the client, you're living in a world where you're not sure what's happening next, and that's fundamentally called an event loop. You are sitting waiting for an event to happen. You don't know which event is coming next, but you have a way to deal with it when it occurs. And you can attach event handlers to different things on the page. So if the user clicks this button, here's what you do. If the user drags this thing from here to there, here's what you do. And as you can imagine, every one of those is expressed by passing a function to something saying, here's what you do function. On the server, life is very different because from the point of view of the server code, every server request looks the same. You wait for a request to arrive, and you know it's an HTTP request. You parse it and figure out which function to call. You call that function. Maybe it talks to the database or does some computation. And eventually, it returns something back to the client, a JSON object or an HTML view or whatever. Every single server request follows the exact same sequence of steps in the same order all the time. Now, does that mean that those server requests don't sometimes block? Sure, going to the database could be expensive, but most modern operating systems have a way to handle that by either having multiple threads on the server or multiple copies of the server process. So you still have the issue that when the server is hung up doing something, other requests get to run. It's just that unlike this scenario, you don't have to manage it yourself. So my point of view happens to be that if the programming model you're dealing with is fundamentally task parallel, which means every task has basically the same structure, basically the same set of steps, but you need to have multiple of them in flight at the same time in case one of them gets hung up. Blocking imperative languages are a great fit for that because the underlying thread system does the work for you of deciding when it can schedule a thread that's runnable because another one's blocked. But if you're in a world where you don't know what's going to happen next and you're sitting there waiting for the user to do something, then in a world like that, event-based programming makes a lot of sense. You have an event loop that waits for the next thing to happen and you react to that thing. And because there's no concurrency in JavaScript, you have to react to the thing by never blocking. Anything you're going to do has to return immediately. So you can kick off a request to the server, but you can't wait for the answer. You have to provide a function saying, when and if the answer eventually comes, call this function. Or if the answer comes back and it's an error, instead call this other function. Or if it times out, you've waited a certain number of milliseconds and nothing has come back, then call this function. And you end up having to manage it all yourself. So that's my 2 cents on models of programming and why I think JavaScript is potentially a better event-based fit for user-facing stuff than for server-side stuff. And I think the server-side frameworks have made a lot of progress in making it possible to write code that essentially looks sequential. The only improvement over that I can think of is to write code that actually is sequential and have the operating system do that management for you. It's probably true that if you get very good at this style of programming on the server side, you can do more things in less memory by doing this sort of event loop style programming compared to the amount of memory it would take to have n copies of a task and have the OS manage it for you. So there's sort of a standard argument that if you can get this kind of programming right, which is difficult because debugging asynchronous code is inherently tricky, right? You do something and then sometime later in a disconnected place you deal with the response. But you get more bang for the buck out of your servers if you can do this. I would rather pay for more servers and spend less programmer time if it simplifies the programming model, because the number one thing that I have to worry about is things don't work correctly, right? Performance is great to optimize after you've gotten things to work correctly, and I just think picking the right tool for the job is a way to maximize getting things to work right in less time. So that's my view.